Okay, so today we're going to solve radical equations, and then we are going to check our answers afterwards to make sure that our answer makes sense. Now, there are specific things you need to do when you're solving radical equations. First of all, if there's only one radical in the problem, so we have one radical, so one radical in the problem, then we want to isolate the radical. What does that mean if I say I want to isolate the radical? Get it by itself, yep. Okay, so I want to get the radical by itself. So what's the first step I need to do then for this problem? Subtract the 5, yep. So we want to move the 5 to the other side. So we have the square root of x plus 1 equals 11. Then once I get the radical isolated, then we're going to, then we'll raise both sides to the power of the index. So what's the index here then? 2. So that means I'm going to square both sides then. So we have x plus 1 equals 121. And subtract 1 from both sides, so x equals 120. Then we want to check our answer, and you can write it down, check it, you can put it in your calculator and check it. So for this one, let's just type it in our calculator and check it and see if it works. So we've got 5 plus the square root of 120 plus 1, and enter, and that does equal 16, so we did it correctly. So you want to make sure you do check your answers to make sure that it makes sense and that your answer works. Let's try one more. We'll do another one like similar to this. All right, so once again here, we have a single radical in our problem. So we want to isolate the radical. So in this case, we have, here's our radical, the cube root of 5x minus 7. Well, what else do I have on that side? Okay, I have a 7 there. And that 7 is being multiplied by it. So my first step here then is going to be to divide by 7. So we're left with just the cube root of 5x minus 7 on the left and 12 on the right-hand side. Okay, so step 1, we isolated the radical. So step 2, we're going to raise both sides by the power of the index. So we're going to cube both sides in. So we get 5x minus 7 equals And I don't know what 12 to the third power is. 1728? Okay. 1,728. Okay. So now we just have a very simple linear equation we need to solve. So add 7 to both sides, and then divide by 5. And 347. Okay, so then we want to check that. So 7 times the cube root of 5 times 347 minus 7 equals 84. So we need to check to see if that works. And I can use my calculator for this still. So 7 times, and if we hit the math key, that has cube root. Number 4 is the cube root of 5 times 347 minus 7. And we got 84. So we did it correct. But it is important that you do check your answer in one way or another, whether it's writing it all out on your paper or using your calculator to check it. You should do that. Okay. All right, so let's look at ones that have a radical on both sides of the equal sign. Or there's more than one radical, we'll say. Okay, if there's more than one radical, the first thing you want to do is make sure they're on opposite sides of the equal sign. And that's the first thing you got to make sure of, that they're on the opposite sides. And then we can raise them to the power of the index. Raise both sides to the power of the index. Now this one is actually a little bit trickier because of this 3. Now we're raising everything, and we're squaring everything. So on the left side we have 7x plus 2. Now on the right side though, we have that 3 on the outside. Okay? So I have to raise that 3 to that power also. Okay? So 3 squared is 9. So we have 9 times the quantity 3x minus 2. Okay? So if we have a number outside the radical and we have to raise both of those to eliminate the radical, then you still have a product there that you have to multiply. So before I can solve it, I have to distribute the 9. And then we solve it. So we get x equals 1. So let's check this one. Square root of 7 times 1 plus 2 equals 3 times the square root of 3 times 1 minus 2. So let's see, square root of 9 equals 3 times the square root of 1. So 3 equals 3. So that works. Okay, so let's look at another type here. So the square root of negative 3x plus 33 equals 5 minus x. So we only have one radical. It's isolated. It's on the side by itself. Okay. So then we're going to raise both sides to the power of the index. So we're going to square both sides. So on the left side, we get negative 3x plus 33. And on the right-hand side, then you have to make sure that you actually square this. So that means that you have to do 5 minus x times 5 minus x. It's not just squaring both of those things, which some people will want to do. Oh, it's 25 minus 10x plus x squared. Is that perfect square trinomial? Now, since we have a quadratic equation out of this, then we need to get everything on the same side, and we want the x squared to be positive. So we're going to move everything to the right-hand side, and then we'll put it in standard form too while we're doing that. So we're going to add 3x and subtract 33 from both sides. So we get 0 equals x squared minus 7x minus 8. And if you want, you could even put the 0 on the other side of it. Doesn't matter which side the equals 0 at. All right. So now we have a quadratic equation, and hopefully we can factor it. Right. So can we factor x squared minus 7x minus 8? 8 and 1. Okay. We get x minus 8 and x plus 1. So we get that x is equal to 8 or negative 1. Now we need to check these. So we'll start with the 8. Square root of negative 3 times 8 plus 33 equals 5 minus 8. So negative 24 plus 33 is 9 equals negative 3. 3 equals negative 3. Is that a true statement? No. 3 does not equal negative 3. So that means that 8 is extraneous and it does not work. Okay. So we try negative 1. And we get the square root of 36 equals 6, and 6 does equal 6, so that checks. So my answer is that x equals 1, or negative 1, excuse me. Okay. 8 was extraneous. So here's the key to you then, all right? If you have on one side or the other, so in this situation here, what you can look at is, all right, so here we're subtracting x. If this side over here is positive, and if I'm going to put the number in for x here, if it becomes a negative value, then it can't be true. Okay? So I knew right away that 8 wasn't going to work because 5 minus 8 is a negative number. Okay? And now if this was minus and it would have produced a positive on the right-hand side, then the same situation would apply. Right? But this is why it's important that you make sure you check your answers so that you can get the right answer too, right? Because there might be extraneous solutions. One more. I think this is the last one. Yep. Okay. If I have fractional exponent or rational exponent, okay, we're going to raise it to the power of the reciprocal. Or I should say raise to the reciprocal of the power, or the exponent. So what's the reciprocal of 1/3? 3. Okay? And the reason is because this is the same as the cube root of 5x plus 7. So since it's the same as the cube root of 5x plus 7, then it makes sense to cube both sides because 3 is the index. So we're going to raise both sides to the 3rd power. What that does then is, what's 1/3 times 3? When we multiply those two exponents together using that power property, it just gives me 1 there. So I have 5x plus 7 on the left and 3 cubed, or 27, on the right. And then we just solve it. And we could check this with our calculator, because we can do fractional exponents. So we have 5 times 4 plus 7 raised to the power of, and we can just type in 1 divided by 3 there. That'll work. And we get 3. All right, so you guys go ahead and do this one. Okay, so we square both sides. So we've got 4x squared equals 4x plus 8. So we get everything on the same side, so we're going to subtract 4x plus 8. So we get 4x squared minus 4x minus 8 equals 0. So what are we able to do now? There's one thing we can do before we factor it. Yeah, we can divide everything by 4. So we get x squared minus x minus 2 equals 0. So now we can factor x minus 2 and x plus 1. So here we get x equals 2 or negative 1. And if we go to check it this time, if I put negative 1 in here for x, I'm going to get negative 2 on the left-hand side. And you can't take the square root and get a negative. So negative 1 is extraneous. So my answer is just going to be x equals 2.